Today we're going to talk about all sorts of different graphs. So do me a favor, take out your notebook, pencil, and probably a calculator. Label the next page in your notebook, lesson 7.2, graphs. This one's going to be a long one. There's 38 pages to this lesson, so it's going to take a little bit to get through. Feel free to pause and take notes or take a break whenever you need to. So we're going to start with frequency tables. Frequency table, this is what I want you to have in your notes. Frequency table is a way to organize data. So for example, if I wanted to count the cars or count the different color cars that drove by my house, I would do the color on this side and I would say, well, let's do black and white and blue. We'll start with that. And then the number, I'm just going to keep track with tally marks. So a black one goes by, a white one, another black one, a blue one. If I get to 4, then number 5 crosses them, so it's easier to count. So I just have tally marks that organizes my data. So that way then I know how many. So black cars, I had 5. White cars, I had 3. Blue cars, I had 4. It's just a way to organize data. Now let's take a look at bar graphs. Again, we're going to start with our definition. Our bar graph shows specific data in specific categories. And the word specific is important because we're talking about just one number down here. And eventually we're going to see what I mean by that. So this is Leon conducts a survey to find the number of people in each car arriving at his school gate between 8:30 and 9. So he had 1 person, 2 persons, 3, 4, 5. So there were 8 cars that had only 1 person in it. There were 20 cars that had 2 people in it. There were 22 that had 3 people in it. So then we can answer questions related to this. So how many cars contained 1 person? So here's our 1 person. It goes up to 8. So there were 8 cars that had 1 person in it. Letter B, how many cars contain more than 3 people? So not 1, not 2, not 3, but 4 and 5. So 4, it looks like we had 10. 5, it looks like we had 4. So there were 14 cars that had more than 3 people in it. This one's kind of the same one. How many cars contained at least 3 people? Again, it's the same numbers. Because it had, or 4 people, I'm sorry, so it had to have 4 or 5, nothing less. How about how many cars contained less than 2 people? So again, we're not using 5, not using 4, not using 3. We're going to use 2 and 1. So 2 had 20, and then 8, so we had, whoops, we don't want the 20, it had less than 2, so it would only be 8 cars had less than 2 people in it. So let's try this one on your own and see about coming back. But this one contains mean, median, and mode and range. So we're going to see how we find it. The bar graph represents the scores from a quiz. Children were asked to name 6 boy bands in 30 seconds. Each score represents the number of correctly named bands. So that means 4 people listed 1 band. So I got 1, 2, 3, 4 that has 1. 2 people said 2 bands, so that's a 2 and a 2. 1 person said 3 bands, so that's a 3. Nobody said 4. We had 5 people that said 5 bands, so 1, 2, 3, 4, 5. There's our list of data. So how many people took the quiz? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 people took the quiz. 12 students, I should say, took the quiz. What was the mean? So we have to add them up and then divide by 12. So if I add all of these up, I get 36, and I'm going to divide by 12. So that means the mean score is 3 bands named. So now what's the median? Median is the middle number. We have 12, so I'm going to count 1, 2, 3, 4, 5, 6. Make sure I have 6 on the other side. 1, 2, 3, 4, 5, 6. So what's between 2 and 3? We add 2 plus 3. That gives us 5. Divide by 2. Our median, is 2.5. Mode, which one occurs most often? That would be 5. And then the range, we have to do 5 minus 1, so our range is 4. Now we have a double bar graph. Again, add this into your notes. Compares two sets of data in specific categories. So let's go ahead and answer our 3 questions. Just ignore the smart notebook thing. Couldn't get rid of that. Kimberly Elementary School surveyed its students to determine their favorite vegetables. They got broccoli, peas, and spinach, or broccoli, peas, spinach, and beets. The purple ones are their lower elementary students. The green bars are their upper elementary. So do more lower elementary students like peas or spinach? So we're going to look at the purple one. We have peas and we have spinach. So which one do they like more? That would be spinach. Do more upper elementary students prefer spinach compared to beets? So now we're looking at upper elementary and we're looking at spinach and beets. So here's spinach, here's beets. Which one has, or how many more? So spinach is 100 and beets is only 10. So that means 90 more like spinach to beets. And the last question, even behind the words here, how many lower elementary students chose peas or beets? So again, we're looking at lower elementary, peas and beets. So we're looking at this one and this one. We're going to put them together. So we have 20 for peas and we have 60. So that means 80 students chose peas or beets. Last one for our bar graphs. Let's go ahead and answer A, B, and C. And again, feel free to pause the video, try answering them yourself, and then come back. Letter A, how much aid did Libya receive from the U.S. in 1975? 75 is purple, Libya. So we go across, and that would be $2. How much more aid did Nepal receive in 75 than in 65? So we're going to go to Nepal. I want to know how much more. It goes from $2 to $3, so that's $1 more. Which country got less aid in 75 than in 65? So basically we want it to go down from their green to their purple bar. This one stayed the same. This one went up. This one stayed the same. Libya is the only one that goes down. So our answer is Libya. So now let's talk circle graphs. And you should be familiar with circle graphs, but we're going to do some proportions to help find our answers. So we're going to start with what belongs into your notes. We got to add a couple of words in here. So data shows data as part of a whole. So the whole circle is the whole thing. Percentages must add up to 100%, and the angles have to add up to 360 degrees. So letter A, this one shows the results of a survey that was carried out to find how students traveled to school. So which one was the most common? We'll just take a look at the spaces. Which one has the biggest spot? That would be the bus. What fraction of the students traveled to school by car? So here's our car, and that takes up 1/4 of our circle. So if 6 students traveled by car, how many students took the survey? So 1/4 times 6 over 1. So that would be 4 times 6. Sorry, not 1/4. We would have 24 students took the survey. So a supermarket chain sold 3,600 packets of sausage last month. The pie chart shows the different flavors. So here's where we're going to use proportions. Letter A, how many packets of vegetarian sausages were sold? So we know that they sold 3,600. What we don't know is how many were vegetarian. So we look at our vegetarian. That gives us 90 degrees because of our little right angle symbol out of the 360. So now we have a proportion set up. I know that I'm going to multiply by 10. So 90 times 10, I got 900 packets of vegetarian sausages were sold. We're going to do the same thing with beef sausages. So I'm going to set up my proportion, again, out of 3,600. And out of 360, I'm going to go to beef. That's 150 degrees. So again, I'm going to multiply by 10. So 150 times 10 is 1,500 beef packets, were sold. So now let's go into line graphs. Again, we're going to start out with our notes. A line graph shows data changes over time. Whoops, let's use a pen instead of a highlighter. Changes over time. So this line graph shows midday temperatures over 7 days. So what was the lowest temperature and on what day? So we just look at the line graph. We find the lowest temperature. That gives us 19 degrees on Thursday. So there's our lowest temperature on which day. Letter B, on what day was the midday temperature 26? So we go to our temperature side. We go to 26. We go over. Here it is. That would be on Tuesday. You just have to know how to read them. Again, try it and see if you can answer the questions and then come back and see how you did. So this graph shows Julie's test results over half a term. So they go weeks on the bottom and their marks or their score on the side. So which week was Julie's mark the same as the previous week? So if you look right here, it goes straight across. So week 6, it did not change from week 5. In which week was Julie's mark lower than the previous week? So I'm looking for it to go down. So right here, it went down. Here it went up, here it went up, here it went up, here it stayed the same, here it went up. So it was week 2 that it was lower than week 1. What's the range in Julie's test scores? So the highest test score she got was 10. The lowest was 3. So 10 minus 3 is 7. And then the question is, what is the mode of Julie's test scores? In other words, which one happens most often? Well, there were 2 that were the exact same, which would make it 8. So now let's move on to histograms. And histograms are slightly different than bar graphs. So again, we're going to start with what goes into your notes. And we're going to fill in the words. This shows a range of data values in intervals is the best word to say it. Intervals of the same size. So if you take a look, here's our histogram right here. We have intervals of 0 to 4, 5 to 9, 10 to 14, and so on. Each of those intervals is the same size. They're all the same size, but we don't know specific data in it, but we know how many times it happens within there. So this one is internet access at home. So we know that 3 students said 0 to 4 times a month. We know that 5 students said 5 to 9 times a month. We don't know which one said 5 or 6 or 7 or 8 or 9, but we know they are somewhere in that range. So the question down here says, can you tell exactly how many accessed the internet 10 times? No, we cannot. We know how many accessed it 10 to 14 times, but not just 10. So let's try answering these together. The histogram shows the number of hours that students in a class slept last night. So how many students slept at least 8 hours? So that means at least would be 8 to 11 and 12 to 15. So I know that's 3 from 12 to 15 and 8. So we add those together and we got 11 students slept at least 8 hours. Letter B, how many students slept less than 12? So we know we're not going to include this. So we've got the 8 here. We have the 8, 4 to 7, and we have the 2. So 8 plus 8 is 16, plus 2 more, we get 18 students slept less than 12 hours. Again, try answering the questions on your own and then come back and see how you did. Again, we're going to deal with some things that we're going to have to solve. Histogram shows time it took students to run a mile in PE. Which interval contains the fewest data values? So which one has the lowest bar? That would be 9 to 10 minutes. How many students are in the class? Well, we have 2 that went 9 to 10. We have 12 that ran at 11 to 12. We have 11 that ran at 13 to 14. And we have 9 that ran at 15 to 16. So if we add that up, 9 plus 11 is 20, plus 12 is 32, plus 2 more, we have 34 students in the class. Letter C, how many students ran the mile in 12 minutes or less? So here's 11 to 12, so here's 12 minutes or less. Add those two together, 12 plus 2, that gives us 14 students. And the last question, what percent of students ran the mile in 12 minutes or less? So we're going to set up a portion, and I'm going to do it above. I got 14 students out of 34. I want a percent, so that's out of 100. So I'm going to divide by 0.34 to get 100. So 14 divided by 0.34 gives us about 35%. We round it to a whole percent. Next we have stem and leaf plots. Again, we're going to start with what goes into your notes. Stem and leaf plot, here's our definition. Let's fill in the words here. It says orders numerical data and shows how they are compared, would be the best way to say it. They're in order. That's one thing that we like. So I want you to take a look at this. This is our stem. This is what is generally the tens column. This is the tens number. What is on the leaf, sorry, I wanted to do a different color. These are the ones. These are what's in the ones column. So like these numbers right here, this would be 6 and 8. The numbers on here would be 12, 16, 18, and 18. If you have to rewrite the whole thing, you can. But notice that they're already in order from least to greatest because we start up here. This is the smallest. Our biggest number down here is 59. And I'm not going to write all of them out. What weights are represented in this plot? Weights of pumpkins is what we're doing. It's the weight of 15 different pumpkins. And it goes anywhere from 6 pounds to 59 pounds. So how many pumpkins weigh more than 10 pounds? Well, here is 10 pounds right here. This would be 10 right here. So we don't have a 0. So we have 12, 16, 18, 18, 20, 21, 23, 26, 29, 32, 34, 38, and 59. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 weigh more than 10 pounds. So we have to find the mean of the data. So that means we have to add them all up. So if I add 6 plus 8 plus 12 plus 16 plus 18 plus 18, and I keep on going, I add them together, I get 360 divided by the 15 pumpkins I know I have. The mean is 24 pounds. Now the median is kind of nice because it's the middle number. I know I have 15 pumpkins. So here's 1, 2, 3, 4, 5, 6, 7. So this one right here would be the one in the middle, which is 21 pounds. Let's do another one. This is a stem and leaf plot that shows information about plant heights. So again, if you look, we have our tens in our stem and our ones and our leaves. So this would be 1, 2, 4, 5, 6, 8, 9. And then we start the next row. Starting with a 1, this would be 10, 11, 11, 15, 17. Here's our 20s, 22, 25, and then 36. So what are the heights represented in this plot? Anywhere from 1, and here's our key, 1 inch up to 36 inches. Find the mode. Mode is the one that occurs most often. So if you look, I have 2 11s, so that would be 11 inches would occur most often. So now here's a question that we're going to get quite often is which statement is not true. So I want you to go through all of them and decide whether they're true or false. Most plants are less than 20 inches tall. So here's our 20 inches, and here's everything is less than that. So yes, most of them are 20 inches or less. The median plant height is 11. Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So again, I'm going to count to 8. 1, 2, 3, 4, 5, 6, 7. Here's our median right here, which is 10. So this one is false because the median is 10 inches. The range of the plant height is 35. So we're going to do is 35. So we're going to do 36 minus 1. That's 35. That is true. The plant height that occurs most often is 11 inches. Well, we already answered that because that's our mode, so we know that is true. So which one is not true? That would be the second one. The median plant height is 11. The next graph we have are scatter plots. And these you're basically going to be looking at the relationship between two things. So we're not going to put down a definition quite yet, but I'm comparing two items, basically. Here I'm comparing fat grams in a sandwich and calories in a sandwich. So let's answer the questions. How many calories are in the sandwich that contains 17 grams of fat? So we look down here. We have 17 would be right about here. There it is. So our answer would be 400 calories. Then let's go to the second question. How many grams of fat are in the sandwich that contains 600 calories? So now I'm going to go to calories, 600. I'm going to go over until I hit the dot. Then when I go down, I see that it has 30 grams of fat. And the last one. What tends to happen to the number of calories as the number of fat grams increases? So as our fat grams increase going this way, our calories generally tend to go up. So they go up or they increase, one of the two. I don't care which way you explain it. So let's look at the same scatter plot. A sandwich has 650 calories. So if we look at calories and 650, we're right here. How many grams of fat would you expect the sandwich to have? So if you go over, where does it generally hit? It goes right around here. So to me, it would have 30 to 35 grams of fat. That would be a good estimate. But like I said, we're going to look at relationships. So I want this into your notes. As as x increases, y increases. That means basically your graph is going to go up. A negative relationship, it goes down. And no relationship, if you look, they're all over the place. There isn't any sort of trend that goes up or down. They're all over the place. So kind of put this in your notes. And let's go ahead and answer some questions. Makes it really easy. All they're asking for is if it's a positive relationship, a negative, or none. So as television sign increases, so does the price. So this would be a positive correlation or a positive relationship. Age and pets owned. If you look, there's dots all over the place. So there is no relationship here. No correlation, no relationship. Let's do the same thing on the next page. Take a moment, figure out what kind of relationship it has, positive or negative or none. Come back and see how you did. So for number 2, I would say it has a positive relationship. It's going up, generally speaking. And number 3 has a negative relationship. So the last one I believe we are doing is a box and whisker plot, and this one is probably the most challenging. You don't have to write anything down on this page exactly, but I would like you to kind of, here's what I guess I would like you to do. Draw this picture and label the dots, okay? So we have the lower, we're going to call this one is the lower extreme. It is the lowest dot on our box and whisker plot. The top one is the upper extreme. And basically each one of these parts is 25%. So this is a whisker. This represents 25% of the data. We don't know what all that data is, but we know that's 25%. Same thing with our upper whisker. This is 25%. Same thing with our box. Here's our box. This is our median right here in the middle. And so this is 25%, the lower part of the box, and the upper part of the box is 25%. It just divides our data into 4 parts. That's it. So let's go ahead and take a look at this one. Again, this is our lower extreme, our lower quartile, our medium, our upper quartile, and our upper extreme. So it says the left whisker is longer than the right whisker. So they're talking this is longer than this side. So the data are more spread out below the first quartile than above the third quartile. The range is 72 minus 50, which is 22. So here's our upper extreme, so that's 72. Our lower was 50, so there's where they've got those numbers. So let's go ahead and answer this question. What they want to know is which statement is true about the double box and whisker plot. And it's just 2 sets of data. So we have standardized test practice, we have your class, and we have your friend's class. Half the test scores in your class are between 85 and 100. So here's 85 and here's 100. Now remember, I said each one is 25%. So this one is 25%, this one is 25%, and this one is 25%, which gives us 75%. Now, is that half? No, that one is false. It's 75%. Next one, 25% of the test scores in your friend's class are 80 or above. So here, I'm going to use a different color. So we have, this is 80 and above, this is 25%, this is 25%. So that means it's 50%, not 25. So this is false. The medians are the same for both classes. So here's my median for my class. Here's my median for my friend's class. They are not the same. That is false. So let's look at the last one. The test scores in your friend's class are more spread out than the test scores in your class. Take a look at the spread out on your friend's class. They start way down here at 60 and they go up to 100, where yours starts about 67 and goes up to 100. So yes, they are more spread out. So letter D is our answer. This one says, what conclusions can you make from the double box and whisker plot? So we're basically selling surfboards. We have shop A and shop B. And the things that we can conclude, I look at shop A, and their lowest one is 300 and their highest one is 900, which is more expensive than shop B. So I can say they're more expensive. Their median is also higher as well. Shop B, I can say has a shorter range. Look at how far their range is compared to shop A. So they have a shorter range. Their median, the shop A has a higher median. Because here the median for shop B is 400. It's 500 for shop A. So shop A has a larger median. So we made 3 conclusions. So let's answer A and B. What is the range of the upper 75% of each brand? So let's take brand A. I want the upper 75, which is this 25, and this 25. So it goes from 3.5 up to 7. So 7 minus 3.5. The range for brand A is 3.5. Let's do brand B again. We're looking at this one, and this one. So the highest we'll say is 6 minus, we'll say what, 3.3, maybe 3.4, something like that. We'll say 3.4. So we subtract those and we get 2.6, if I do my math correctly. Letter B then says, which battery has a longer battery life? If you look at brand A, it takes up more space. Their median is higher, their highest is higher. So I would say brand A has a longer battery life. Now, do we know that for sure? No, but based on our box and whisker plot, that's what we're going to decide. So again, we're going to answer the 2 questions. Here we have, this is the stem and leaf plot that they used. So we have specific numbers, but then they used it to make a box and whisker plot on the same data. So find, the question, letter 9A says to find the least and greatest data numbers in the stem and leaf plot and how they're shown on the box and whisker. So the smallest number on the stem and leaf plot is 17, which if you look right on the number line, that's on 17. Our highest number is 51, which again is our upper extreme on this one. So what are they called on the box and whisker plot? Lower extreme and upper extreme. Use the stem and leaf plot to find the median of the data, and how does that show on the box and whisker plot? Well, we're just going to look at the box and whisker plot. The median is right here in the middle of our box, which is 23. So we know our median is 23. Same box and whisker plot. The upper whisker extends from 27, which is right here, all the way up to 51. What possible values are in the lower whisker? So there's our upper whisker. Our lower whisker is a lot shorter. It goes from 17 to 18. So literally it's 17 to 18. I like this next question. What fraction of the data lies in the box between the upper and the lower quartiles? I'm hoping you know this one now, because remember I said each part is 25%. So that's 25% and that's 25%. So that's 50%, which they also ask. For what fraction is 50%? That's 1/2. So this one, I just want to name some points. I want you to name this box, basically what I would like you to do. I want the lower extreme, the lower quartile, the median, the upper quartile, and the upper extreme. So let's go ahead and start. Every dot is one of them. The lower extreme is right at 17. The lower quartile is the next dot, and that's at 18. The median is the dot in the middle of the box, which gives us 23. The upper quartile is the one on the end, which is 27. And the upper extreme is up here, which is 51. Whew, that was a long one. Your homework is the 7.2 Interpreting Graphs packet that you will get in class. If you have questions, let me know.